So let's see if we can make some sense of this, of what appears to be gibberish here. So I have a couple of different compositions. I have little f composed with little f, so we have to be case sensitive. And then, so here, and then I have this big G is the square of big F, which was little f composed with little f. So we're just gonna break it down one step at a time. So in order for, and then you also know that blah, 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 we'll get to that stuff later. So here is where we're gonna start, but we're gonna do that by not having the 6 in there right away. We're just gonna say, okay, well, what is f prime, capital F prime of x? And I'm going to use my notation like that. And I have to find little f of x. And so reminder, what does the chain rule says? Well, it says identify what the outer function is. Well, this one right here is my outer, and it's also the inner, which makes things a bit weird, but not that much. All right, so first, derivative of the outer function is f prime of blank, and then multiply that by the derivative of the inner, which is f prime of x. And then in the outer function goes whatever it had before, which was little f of x. So this is the derivative of a function composed with itself, which looks a bit messy, but it's not too bad. Now, once I know that, I can then figure out what f prime of capital F prime of 6 is. It's just going to be little f prime of little f of 6 times little f prime of 6, which should be given above here. So f of 6 is 11. So then I need to know what is f prime of 11. And f prime of 6 is given over here at the end as 5. And f prime of 11 is 11 up there. So then I get 11 times 5 is 55. So now I know what capital F prime of 6 is. And I really have to do all of that before I can deal with G, because G is related to capital F. So now let's try capital G. And so like before, I'm going to do capital G, find its derivative just with an x, not with the 6 yet, which means I need to think about what is the derivative with respect to x of the square of capital F of x. And then I have to identify the outer and the inner. And so my outer function is the square, and the inner function is my capital F. Applying the chain rule here, the outer goes first. The derivative of a square is twice whatever you were squaring. I happen to be squaring capital F of x. Then multiply by the derivative of the inner. The derivative of capital F is just capital F prime of x. So that's what the derivative of a square of a function looks like. It's twice the function times the function's derivative. That's what the chain rule tells us. Now we think about the 6. G prime of 6 is equal to twice capital F of 6 times capital F prime of 6. All right, well, we just found capital F prime of 6 there. So cool, I know this thing right here is a 55. Can I figure out what capital F of 6 is? I don't have that yet, so I'm just going to do a little work down here to figure out that. What is capital F of 6? Well, based on the original definition up here at the top left, it is little f of 6. Order of operations is we got to do this inside first. The little f of 6 was given right here as 11. So now I need to know what is little f of 11. And that was also given right here. That would be 3. So this tells me capital F of 6 is 3. And I'm done. Multiply those 3 numbers, and I got an answer. So this was just an exercise in what does the chain rule tell us again, and how do function compositions work? That was a cool puzzle. So again, it took me kind of 3 stages of work to figure that out. Writing down everything. The more you write down, the more your brain can look at it and say, yeah, I think you got that right. But if you don't write it down, how can you rethink it? So moral, write stuff down, lots of stuff.